You've probably heard the big promise from the airline industry, right? A future where we can all hop on a plane, fly wherever we want, and do it completely guilt-free. The goal they've set is net zero carbon emissions by 2050. It sounds amazing, but how real is that promise? Let's dig into the research and ask the big question. So, can we actually do it? Is this vision of clean, green flying a realistic flight path, or is it maybe just a comforting myth? To figure that out, we need to look at the industry's master plan for getting there. And the industry has a very confident answer. It's this sort of silver bullet that's supposed to decarbonize the skies without any of us having to change our travel habits one bit. It's called Sustainable Aviation Fuel, or SAF for short. The whole idea is to just swap out the old fossil-based jet fuel for this new stuff. Simple, right? But what does that look like in the real world today? Well, this is where reality hits home. This chart shows a pretty staggering gap. Right now, more than 99.9% of all jet fuel is still fossil-based. Sustainable fuels, they make up less than 0.1%. So to get from here to that 2050 vision, we have a very, very long way to go. So, to understand if we can even begin to close that gap, we first have to ask, what is this stuff? What exactly are we betting the entire future of aviation on? Let's decode it. Okay, so SAFs basically come in two main flavors. On one side, you've got biofuels. You can think of these as fuels made from organic stuff. Things like used cooking oil, leftover straw from farming, or even algae grown specifically for this purpose. Then, on the other side, you have e-fuels. These are totally synthetic. They're literally made by grabbing carbon dioxide out of the air and combining it with green hydrogen, which itself is made using renewable electricity. But are these technologies actually ready to power the world's airplanes? This table gives us a really important clue. It uses something called a technology readiness level, basically a score for how mature a technology is. And as you can see, only one pathway, the one using waste oils, is truly at a commercial scale today. A lot of the others, like those promising e-fuels, are still in the demonstration or even prototype phase. They are a long, long way from being mass-produced. But you know, having the technology is only half the battle. The next challenge, and it's a huge one, is all about resources. The sheer scale of what we would need is kind of mind-boggling. Just to wrap your head around this, take a look at this quote. To fuel its planes with biofuels, the aviation industry thinks it would need somewhere between 10 and 30% of all the sustainable biomass available on the entire planet. That is a massive slice of the pie. And that, of course, creates a huge global tug-of-war. See, aviation isn't the only industry trying to go green. You've got shipping, trucking, power plants. They are all fighting for the exact same limited resources. That biomass, that green hydrogen, that captured CO2, and crucially, all the clean electricity needed to make it happen. Now get ready for this next number because it's a real jaw-dropper. If we decide to go the e-fuel route, the math gets even crazier. The industry's own research suggests that by 2050, aviation alone could eat up 20% of the world's entire electricity production. That is an almost unbelievable amount of power just to keep planes in the air. And this chart really puts that into perspective. Look at the bar on the left. That's the electricity used by the entire global transport sector today. All the cars, trucks, trains, and ships combined. Now look at the bar on the right. That's what aviation alone would need to run on e-fuels. It's not even in the same ballpark. We're talking about more than 20 times the electricity just for flying. Okay, so the resource challenge is immense. But let's pretend for a second we could find all that biomass and generate all that electricity. Well, there are still other major hurdles on the runway, from a history of failure to some pretty cold, hard economics. And history gives us a pretty good reason to be skeptical. Back in 2008, the industry set a goal, 10% sustainable fuels by 2017. And what happened in 2017? Actual use was pretty much zero. So they set a new, much lower goal for 2025. This pattern of setting big goals and then quietly missing them has been going on for over a decade. So why keep missing the targets? Well, a huge part of the answer is just simple economics. Right now, sustainable fuels cost anywhere from 2 to 7 times more than regular old jet fuel. With that kind of price difference, there's just not much incentive for airlines to make the switch. And making that switch would require an absolutely mind-boggling amount of money. The estimated investment to build all the refineries and plants we need is up to $1.7 trillion. So the big question is, who's going to pay for that? Well, this quote describes the problem perfectly. Researchers call it a low investment trap. It's like a giant standoff. The fuel producers won't build these expensive new plants unless airlines promise to buy the fuel, but the airlines won't sign those expensive long-term contracts without a guaranteed supply. Everyone is just waiting for someone else to make the first move, and so progress just stalls. So let's just recap. We have enormous resource constraints, a history of missed targets, and a massive investment problem. When you put all of that together, the research starts pointing toward a very uncomfortable conclusion. It turns out this whole strategy of just relying on new fuels to save the day has a fundamental blind spot. It's a flaw in the plan that makes all those other problems, the resources, the cost, the investment, even harder to solve. And here it is. The industry's plans are all based on the assumption that air travel is going to keep growing and growing and growing, maybe even tripling by 2050. Think about that. They're trying to solve an already monumental resource problem, while at the same time making that problem 2 or 3 times bigger. And this brings us right to the core finding of all the research we've been looking at. The authors basically conclude that betting on technology alone just isn't going to be enough. If there's any real chance of hitting that net zero target, you can't ignore the demand side of the equation. Which leaves us with this final and pretty provocative question. After looking at the incredible resource limits, the economic hurdles, and this plan for ever-growing demand, you really have to ask, is the only truly sustainable flight path one that involves fewer flights? It's a challenging thought, but it's one that the data forces us to consider.